Welcome my dear student, welcome to my channel Talking Physics with Piyas Sarkar. In the previous day we shall learn about Gauss law and its application in electrostatics. But today we will learn a very important chapter which is very necessary for upcoming HS examination and NEET joint. So the chapter is electrostatic potential or electric potential. So today we learn about electric potential. We may know the sound potential in various cases, gravitational potential, potential energy, kinetic energy, but here electric potential is somehow different from the previous case. So electric potential is, we know the electric potential, but at first we know that potential difference. At first we know about the potential difference. What is potential difference? Suppose a point charge plus Q is situated at a point A in an electric field. If we take another test charge Q0 which is infinitesimally small compared with the source charge Q at a distance R, then if we consider any 2 point B and A on the same line, and suppose if we move this test charge from Q0 to B, that is, we consider that the test charge at any instant is placed at point A, and against electrostatic force it is moved from A to B. Why against electrostatic force? Because this is positive charge, so the electrostatic force or force of repulsion act towards right side. So against this force of repulsion we have to do some external work to move the test charge from A to B. So according to the definition, the potential difference of B and A, that is VB minus VA, must be equal to WAB, that is it moves from A to B, divided by Q0. This is the potential difference between the 2 points A and B. We may define it as that the potential difference between 2 points is equal to work done in moving a unit positive, always the test charge will be unit positive charge from one point to another against electrostatic force. That is, the work done is always negative here because the direction of force and displacement are opposite to each other. The potential difference between 2 points is equal to the work done in moving a unit positive test charge from one point to another against the electrostatic force. Here we consider that the test charge is infinitesimally small, so that the electric field of this test charge does not affect the electric field of Q. And here we can say that the test charge is moved very slowly. Test charge is moved very slowly only to balance the repulsive force, that is its acceleration A must be 0. It does not accelerate. Acceleration is 0. So I hope you know that what is the potential difference between 2 points. So we now learn about the unit of potential difference. From this you can write that the joule per coulomb or Newton meter per coulomb. Now we go with potential of a point. Potential of a point is how we can get the potential of a point. So, potential of a point. Potential of a point charge. Now we can try to find out the potential of a point charge. If we placed a point charge in an electric field, अगर कोई इलेक्ट्रिक फील्ड में एक पॉइंट चार्ज को प्लेस किया जाए तो उसके वजह से इलेक्ट्रिक पोटेंशियल का वैल्यू क्या होगा. सो वी कैन राइट दैट. सपोज अगेन वी कैन मूव दैट at point A the source charge Q is placed. Therefore, this is point B and this is point A. We have to find out this is point P. P is at a distance from the source charge R. Now what is potential? According to definition, a unit positive test charge, suppose Q0 test charge, a unit positive test charge which is situated at infinity, which is situated at infinite position or very wide separation. If we take, we have to take it, does not come of its own, we have to take it. If we take it from infinity to a given point in an electric field, then the work done required for this process is called potential of that point. I repeat, to bring a unit positive test charge from infinity to a point in an electric field obviously is called potential of that point. So at first, for convenience, we say that the test charge is at point A and the difference is A and B is very small. We say it dr. We know that dr, dx, dv is differential form of very infinitesimal small function. Okay. So if due to this test charge the force or electric field or force, if we know that force on the test charge is given by F equal to 1 by 4 pi epsilon naught Q0 divided by R square. We know that this force is expressed by this test charge at a distance R. Now, if we at any instant, if we take that the charge Q0 is situated at A, we have to move it from B against the electrostatic force because it is at right side and we have to shift it towards left side. So the angle is here 180. We know that the small work done in moving the charge from a distance dr is F dot dr. Now if we take F dot dr, that is F dr cos 180. Cos 180 means minus 1. That is F minus F dr. We can say it minus F dr or minus integration, put the value of F 1 upon 4 pi epsilon naught Q0 by R square into dr. So this is the elementary work done in to shift the or to move the particle from B to A only. But according to definition, we have to move it from infinity to R. So we have to take the value of integration. So the potential at P, potential, okay, no potential, at first we find out the work done only. So work done equal to, we take the limit infinity to r, okay, infinity to r, upper limit r, lower limit infinity, minus, you can write the value 1 by 4 pi epsilon naught q0 divided by r square dr. We can take that minus 1 by 4 pi epsilon naught and q0, as this is constant term, integration infinity to r square, sorry, 1 by r square dr, 1 upon r square dr. So I know you know the integration. So here the work done required is q0 by 4 pi epsilon naught by r. So this is the work done to move or bring by external agent from infinity to that point. So we can know that from the definition that if we can move it from VB to VA, A to B, then we can write it as VB minus VA equal to, what is this, q0 divided by 4 pi epsilon 0 r. We take that VA equal to 0 because we can consider that A is far away, situated in infinity, and for infinity the potential V of infinity must be 0. This is the assumption, okay. So according to definition, if this is work done, then what is the value of potential at B? That is V of B must be equal to W A to B by Q0, you know. Here W is Q0 by 4 pi epsilon naught R divided by Q0. So this Q0 and this Q0 is cancelled. So you can get the value of VB, that is potential at B, is 1 divided by 4 pi epsilon naught Q by R. This is the expression of potential of the point at point B. So we know that from this equation we know that potential is only depends on the separation between the point, as we know that the separation between point A and P is R. So if we take a unit positive charge from infinity to P, then we can get the value 1 by 4 pi epsilon 0 Q by R. So it only depends on R, that is, it is spherically symmetric, and as it depends on R, so we can say that if we draw the point, so if we draw the graph of E and V with respect to distance R, if we take R along x-axis and the value of potential and electric field along y-axis, this is 0, 0.5, 1, 1.5, 2, 2.5 and so on. This is also 0.5, 1, 1.5, 2, 2.5. So when R equal to 1, electric potential we know that 1 by 4 pi epsilon naught Q by R square, and potential is 1 by 4 pi epsilon naught Q by R. So if we put R equal to 1, then E equals to V. So if we take the graph, at first we saw the graph E equal to 1 by R square, that is this type, and this type, and the potential graph is above it. Potential graph is above it. So if we take the graph, this type, this point is equal to V. Okay, so here we know the value of electric field and electric potential. Now we go with numericals. So our first numerical is Let us consider a square. Let us consider a square A, B, C, D. Here the charge is 100 microcoulomb. Here is charge is minus 50 microcoulomb. At point C is the charge is 20 microcoulomb and at D is minus 60 microcoulomb. It is said that any of the side is root 2 meter. So what is the electric field at the center of the square? That is, if we take the point O as center, then what is the electric field? What is the potential at the center? Here we know that as potential energy is a scalar quantity, so also electric potential is also a scalar quantity. So if there is a point and suppose this is a point A and suppose Q1, Q2, Q3 charges are situated in different position, then the electric potential at A will be sum of the potential of this point. Suppose for charge Q1 the potential at A is V1, for charge Q2 the potential of A is V2 and for Q3 potential is V3, then according to principle of superposition total potential at A will be V1 plus V2 plus V3. So if we said this is V1, this is V2, V3 and V4, that is the potential due to 100 microcoulombs at O is said to be V1 for convenience, and for B is V2, V3 and V4. So the potential, total potential is the sum of not on V1 plus V2 plus V3 plus V4. Very simple. So we can write 1 by 4 pi epsilon naught Q by R. What is Q? Q is plus 100. Here the sign of charge can be mentioned. R. R is the half of the diagonal. We know that if this is a square, then this is root 2 meter and also the AD is root 2 meter. So AO will be 2 meter. AC will be 2 meter. So this is 1 meter and this is 1 meter. Okay. Obviously this is 1 meter, this is 1 meter. You know that if the side is said, then the diagonal formula of diagonal I know you will find out. So this is AO is 1 plus all the cases 1 by 4 pi epsilon is comes. So we take it outside the bracket as it is taken is common. Then for this B, that is V2 is minus 50 by 1 plus 20 by 1 minus 60 by 1. Here the charge of the sign of charge must be given. Okay, plus you can say the bracket plus minus 60, put the bracket, then you will omit the bracket. Here the charge, sign of charge, I mentioned sign of charge can be given, but in case of find out electric field, only magnitude is given as electric field is a vector quantity and we have to find the direction separately. But here the case is opposite. So we can 1 by 4 pi epsilon 0 put the value 9 into 10 to the power 9. Therefore 100 minus 50 plus 20 minus 60. So 100 plus 20, 120, 60, 10. That is 9 into 10 to the power 9 into 9 into 10 to the power 9 into 100 into 10. Okay, here the charge are microcoulomb, so all case 10 to the power minus 6 will be get. You can write it here, we can common it because all the charge are in microcoulomb. So you can get the value of potential at O is 9 into 10 to the power 4 volt. Okay, very simple mathematics. This can be done also for triangle. Next we go with another numerical of potential. This is only basic. In the next day we shall do the potential at axial position or bisector position. Okay. Suppose the potential of a single raindrop is 220 volt. Such 27 raindrops collapse with each other, 27 raindrops, to form a large raindrops. We have to find out the potential of these large raindrops. The potential of a single raindrop is 220 volt, it is said. Such 27 raindrops collapse to form a large single raindrop. What will be the potential of this large drop? So, we have to find out that the potential of a single drop we can say it V1 equal to 1 by 4 pi epsilon naught Q by R. Q by R. Q is 220 volt, we can put it later. In this case, in this type of math, we have to, if the radius of small drop is small r and radius of this large drop is capital R, then we have to must find out the relation between capital R and small r. That is, capital R is how much times of small r. So that we can show that 4/3 pi r cube, that is volume of capital R, volume of the large raindrop must be 27 of volume of single raindrops. So 4/3 pi cancel, r cube equal to 27 small r cube or r equal to 3 small r. Okay, and what will be the charge of raindrop if say q, that is 27 into small q, because small q is the charge of a single raindrop. So 27 raindrop must be collapsed so that the total charge is 27 q. Put the value of q from here, that is 27 into q is V1 is set 220 volt. Okay, q equal to 220 multiplied by 4 pi epsilon 0 r. Number 2 equation. So we have to find out the one by 4 pi epsilon naught into capital Q by capital R, which is the potential of this large drop. So we can get 1 by 4 pi epsilon 0 is 9 into 10 to the power 9 into capital Q value we can find out 27 into 220 into 4 pi epsilon naught small r divided by capital R. Capital R is 3 into small r. Okay. So, okay, we cannot write it 9 into 10 to the power 9. We can write it as 4 pi epsilon naught, because this 4 pi epsilon and this 4 pi epsilon 0 is will cancel out, and this r will be also cancel out. 9, that multiply 900. So the potential of the large drop is 1980 volt. So हम आशा करते हैं कि आज के लेक्चर आपको बहुत अच्छा लगा है. You will understand it. So for get such interesting video, and if you learn physics by step-wise, you can subscribe my channel, view my channel, and please comment me in my box so that I will try it. For today, thank you very much.
Like the video.